Welcome to Spelling Bee Ninja, where we dive into the fascinating world of learning. Today, we explore how mathematics shapes our understanding of the Earth and its places through coordinates. If you're eager to discover how math helps create maps and guides us in our daily lives, you're in the right place. Join us on this journey, and don't forget to subscribe for more engaging educational content that helps expand your knowledge and curiosity. Coordinates are fundamental in describing locations and enabling navigation across the globe. Imagine trying to explain to a friend where a treasure is hidden without coordinates. Saying it's near the big tree doesn't cut it, does it? We rely on coordinates, sets of numbers that pinpoint exact positions in space, allowing us to share precise locations, whether on a map, in video games, or in everyday situations. This universal language of coordinates consists of numbers that signify distances from reference points. For instance, on our planet, we use a system with longitude and latitude. Without this system, we would struggle to communicate specific locations. Interestingly, the coordinate system we use today traces back to the 17th century, credited to French mathematician René Descartes. It is said that he developed this idea while watching a fly crawl on his ceiling, realizing he could describe its location by measuring its distance from the walls. Isn't that cool? Now, let's take a closer look at the Cartesian coordinate system, which uses two intersecting axes. The x-axis runs horizontally, while the y-axis runs vertically. The point where these axes meet is known as the origin, or 0, 0. Every point on this plane is represented as an ordered pair of numbers, x, y, which indicate the distance from the origin along the x and y directions. This system divides the plane into four quadrants, each with distinct characteristics based on the signs of the coordinates. Quadrant I has positive x and y values, while quadrant 2 has a negative x but a positive y. This connection between algebra and geometry revolutionized mathematics. Now, shifting to a global perspective, we encounter latitude and longitude, which create a global coordinate system for Earth's surface. Latitude lines run horizontally and measure distances north or south of the equator, while longitude lines run vertically, indicating east or west of the prime meridian. Together, they create a grid that allows us to pinpoint any location on the globe. For example, the famous city of Paris is located at 48.8566 degrees north latitude and 2.3522 degrees east longitude. This beautiful system makes navigation possible for ships, airplanes, and even our everyday smartphones. Here's a fun fact: 1 degree of latitude is roughly equivalent to 111 kilometers or 69 miles. This means that even minor changes in coordinates can lead to substantial distances on the ground. Now, let's talk about how coordinate systems are essential for mapping the Earth accurately. Mapmakers employ various coordinate systems and projections to translate the Earth's round surface onto flat paper or screens. One popular method is the Universal Transverse Mercator, which divides the Earth into zones, utilizing coordinates to measure positions within each. Mapping from a sphere to a two-dimensional surface always involves some distortion, yet accurate coordinate systems allow maps to minimize mistakes in specific areas. So, why do world maps appear different from city maps? That's because the chosen coordinate system and projection depend on the scale and purpose of the map. In modern times, digital maps utilize advanced coordinate systems alongside GPS data to provide incredibly precise location information. Here's another interesting tidbit: the Mercator projection, developed in 1569, is still favored for navigation despite distorting land sizes near the poles. Speaking of GPS, let's uncover how it utilizes coordinates for navigation. The Global Positioning System is a constellation of satellites orbiting Earth. These satellites communicate signals that your GPS receiver uses to determine your precise location. By measuring the time it takes for signals to reach it from at least 4 satellites, the receiver calculates your latitude, longitude, and even altitude. Today's GPS technology can locate you within just a few meters, with more sophisticated equipment narrowing the accuracy to just centimeters. Isn't that revolutionary? GPS technology owes part of its incredible accuracy to Einstein's theory of relativity. Because the satellites are orbiting high above Earth and at high speeds, their clocks tick slightly faster than clocks on the ground. The GPS system adjusts for this time difference to ensure precision. Now that we've discussed two-dimensional coordinates, let's venture into the third dimension. 3D coordinate systems introduce a third axis, the z-axis, to describe positions in three-dimensional space, allowing us to account for height, depth, and width. The coordinates are now expressed as x, y, z, with x and y specifying the horizontal position and z representing vertical information. This system has vast applications, from video game design to architecture and even medical imaging. With the help of 3D coordinates, we're able to represent objects in the real world with remarkable fidelity. Have you ever pondered how coordinates have impacted navigation throughout history? From ancient seafarers who relied on stars and landmarks to the advanced navigational tools we have today, the evolution of coordinates transformed navigation. The introduction of latitude and longitude in the 17th and 18th centuries provided sailors with a reliable way to assess their position at sea. First, sailors could figure out their latitude using celestial bodies. Then, the creation of accurate timepieces enabled the determination of longitude. And today, GPS technology offers navigation precision unheard of in the past. Did you know that, in the early 18th century, the British government offered a whopping £20,000 prize to anyone who could find a practical method for determining longitude at sea? That challenge was finally overcome by John Harrison, who developed accurate marine chronometers. So, coordinates have become crucial not only for navigation but also for various technologies we use today. Images on our screens, robotics, game design, and data visualization almost all rely on coordinate systems. For instance, in computer graphics, every pixel is defined by coordinates. Can you imagine how different our digital experiences would be without coordinates? Additionally, treasure hunts and geocaching are fun activities where coordinates guide us to hidden treasures, making learning about coordinates lively and engaging. With technology constantly evolving, we must consider the future of coordinates. As we venture into space, new coordinate systems will emerge to help navigation across planets and galaxies. There are also coordinate systems being developed for dynamic environments and even complex data visualization in the realm of quantum computing. Imagine a four-dimensional coordinate system that includes time as a dimension. These advancements will allow us to navigate previously unreachable territories and explore the complexities of our universe with more clarity. Who knows what the future holds? The potential of coordinates is truly limitless. In today's journey, we explored how coordinates are fundamental to our understanding of maps and navigation. We learned about the Cartesian coordinate system and how latitude and longitude provide a global referencing system. We discovered that coordinates help create accurate maps and how GPS technology uses these numbers to guide us anywhere on Earth. Additionally, we touched on three-dimensional coordinates and their applications, along with the historical evolution of navigation through coordinates. Finally, we looked towards the future and the exciting possibilities of advanced coordinate systems. Thank you for joining us on this educational adventure about the remarkable role of coordinates in our lives. We hope you found it both enlightening and inspiring. Remember to subscribe to Spelling Bee Ninja for more fascinating lessons that feed your curiosity and knowledge. Until next time, keep exploring and let coordinates lead the way in your learning journey.